All right, so today is the last day of factoring strategies and notes. After this, you guys will have a practice day, and then you do have a test, a skills test coming up on factoring and all the things that we had done with graphing. So today's goal, we're still in the second section of the quadratic unit, so we're still factoring. That has not changed, but we're focusing on special cases today. And these special cases could be factored using the strategies we've already learned. You can factor these by guessing and checking, but there are some shortcut strategies that you can use with these two special cases. Okay, so the first one that we're going to learn today is called a difference of two squares. So when I think of difference, what math operation comes to mind? And the answer is subtraction. And squares, I am referring to the perfect square numbers that you would have learned in Algebra 1 and geometry. 1, 4, 9, 16, 25, etc. Those are perfect square values because when you multiply a number by itself, it results in that number. So for a difference of two squares, I'm going to give you the formula and show you how it works. So the formula is in the format a squared minus b squared. So it's a binomial, it's only two terms, and both terms have to have perfect square values, or the exponents of the variables need to be an even value. When we factor these, going to factor into two binomials like normal, and in each term, or each factor, you're going to square root the two terms of the original. So if I square root a squared, I'm going to get a, so a times a. If I square root b squared, ignoring the sign, I'm going to get b times b. Because this is a subtraction symbol, in order to get subtraction when I distribute, I need one positive and one negative. So the factors will almost look identical, except the signs will be different. So if we try an example of that, I give you 4x squared minus 9. 4 is a perfect square, 9 is a perfect square, and the x is being squared. So if I set up the binomial factors and follow this approach, what am I going to do to each of these two terms? And the answer is square root them. So when I square root 4 and the x squared, I will get 2x. 2x times 2x is 4x squared. And I'm going to square root the 9, and the square root of 9 is 3. So we'll have 3 and 3. And how do we figure out our signs? That will be one addition and one subtraction. If you were to do guess and check, you would be finding factors of the a, factors of the c, and when you check it, the middle term needs to come out to be a b value of 0. So you could do these by guessing and checking. But the shortcut, if you can remember it, goes a lot quicker. If we try one more of those, 5x squared minus 20. Looking at this, you might think, well, 5 and 20, they're not perfect squares. But you have to think back to that strategy that I've been telling you since day one, is you're always supposed to first, before anything else, look for a greatest common factor. That always should be taken out first. So this has a greatest common factor of 5. If we factor out the 5, we'll be left with x squared minus 40. The x squared minus, not 40, sorry, x squared minus 4. The x squared minus 4 is an example of the difference of two squares. The x is being squared, and 4 is a perfect square, and technically this is a coefficient of 1, which is a perfect square as well. You're going to see me abbreviate when I come back from my leave and we do polynomials later on this year. Difference of two squares, I will usually call a D2S just to save some time in writing out the whole title. That will bring down my GCF of 5 and set up my two binomial factors and square root each of these terms here. So square root of 1x squared, x, and square root of 4, 2 and 2, and the signs need to be opposites. There is our solution. That's one shortcut method. The other shortcut method that we are going to learn is called the sum or differences of two squares. Or not, sorry, not of two squares, of trinomials. Sum or difference of a perfect square trinomial. Because the b value could be positive or negative. I'm actually going to reword that. I'm not liking the way that sounds, so I apologize. I can't really go back and re-record here. Perfect square trinomial is what we're going to call it. But some of these will have positive b values and some of these will have negative b values, but they will all be trinomial. This is the way it's going to be set up. I'm going to give you the formulas, which are going to look confusing right now, but they'll make sense once we analyze an example. If I had a squared plus 2ab plus b squared, what this formula is saying is that the first term has to be a perfect square, and the last term has to be a perfect square. Now the center, if we look at the 2ab, that's saying take the square root of the first and the last term, multiply them together, because the square root of a squared is a, square root of b squared is b. If I multiply them, I get ab, and then double it. That's where that 2 is coming from. So the trinomials I give you have to fall into this specific case, and we'll test that out in a minute here with an actual example. When we factor these, the factors are going to be 100% identical. And we factor them the same way we did the differences of two squares by taking the square root of the a and the b, the first and the last term. So square root of a squared, as I said, is a. Square root of b squared is b. So we're going to have a and b. And the signs are the exact same. You take the sign of the middle term. So plus and plus. You could write it in this format, or you will also see me writing it as a plus b squared, the square of a binomial. If we apply this to an example, I could give you x squared plus 12x plus 36, which could be guess and checked. You can factor it by guessing and checking. But if I give you some really large perfect squares, then this strategy would definitely come into play. To make sure you even have a shortcut, because you can't do the shortcut unless it falls into that category, you have to test it out. So you would take the square root of the first term, which is x. You would take the square root of the last term, which is 6, and you'd multiply those together. So you would get 6 times x, which you would then double to get 12x. So that does match up. So again, you square root the first term, you square root the last term, you multiply them and double it, and that should match up with the middle. That's only to check that this is a perfect square trinomial. So because it is, now I can factor it the shortcut way. So this is going to factor into two identical binomials. And again, I'm not going to write it twice. I'm going to write it once, but then square it. And I'm going to square root the first and last term. Square root of x squared is x. Square root of 36 is 6. Sign of the middle. And that's how you factor a perfect square trinomial. The other one that falls into a perfect square trinomial is very similar. It's just one difference, and that's going to be the sign of the middle term, your b term sign. So I could have given you a squared minus 2ab plus b squared. So the last term is still positive. That always will be positive with the perfect square trinomial. The only difference is when you factor this into your two binomials is the signs. So I'll still have A and B, which are the square roots of the first and last, but because our middle term is negative, these are both going to be subtraction signs. Negative and then another negative would combine to a negative middle term. Or I could write this as A minus B to the second power, since they're the same. If I were to give you an example of this perfect square trinomial, I could give you something like 49r squared minus 14r plus 1. I would want you all to notice that 49 is a perfect square, 1 is a perfect square. So you might think, oh, this could be one of the shortcuts. Let me check to see if the middle matches up. To check, we square root each of them. So I'm going to get a 7r, and the square root of 1 is 1. I multiply them. 7r times 1 is just still 7r, and then I double it to get 14r. Now, I do understand that this is a positive 14r and this is a negative 14r, but when you're checking, you're not trying to verify the sign, you're just focusing on the just the main part of the b value. So you're ignoring the sign. It's okay that that does not match up. So this does fall into a perfect square trinomial case, and it's going to factor into two identical factors. Square root, the first and last, like we already did, to get 7r and 1. And the difference is the middle term will have, or the sign of each binomial will be a subtraction sign. So 7r minus 1 times another 7r minus 1. Okay, and that's pretty much all there is to it. The hardest thing about these examples is just recognizing when you have one. So it's up to you to recognize, do I have a perfect square trinomial? Can I apply this shortcut strategy versus guessing and checking to figure out what goes in each binomial? So that's what you have to study. I'm also going to pull up this summary chart, which you guys will be getting now in class. And this goes through and summarizes all the factoring strategies that you've been learning about over the past few days, which there are a lot of them. So you have to distinguish when to use what. So I'd hit pause at this point. You're going to be getting this. We're going to look over it and make sure you understand when to use each factoring strategy. So it breaks down by how many terms the problem has. And I just want to emphasize above the chart how it says, before you start to factor any problem, always look for a GCF first. Whether there's 2 terms or 10 terms, you can identify and check to see if a GCF exists. And there might not, but you should look for it first. So number of terms, if there are 2 terms, look to see if there is a GCF and factor it out. And then all the way to the right, I have provided an example of what that looks like. GCF, though, is not necessarily the only step. Sometimes after you factor out a GCF, you have to go further and apply one of the other factoring strategies. So let's look at those ones. When there are just 2 terms, 2 only, then that could be a difference of 2 perfect squares, a difference of 2 squares. So if you'll notice that the only boxes that have 2 terms that are binomials are GCF or a difference of 2 squares. So if a problem I present to you has 2 terms, but it's not either of those, then as of right now, it's either not factorable or we haven't learned a strategy for it yet. Okay, so you would write down not factorable because I wouldn't give you any type of problem in which we haven't learned that factoring strategy. So difference of 2 squares, it gives you your formula here and then provides you an example. The rest of the boxes are all about 3 terms. So trinomials, factoring quadratic trinomials. The first one is the guess and check method. So you could have x squared plus or minus bx plus or minus c, depending on your signs. Or maybe you have an a value that's not 1. So there's the quick guess and check when the a is 1. And that's when you're just focusing on finding the factors of c that'll combine to b. And an example of that is right here. So factors of 30, that would give you negative 13. And there's the slightly longer guess and check. When the A value is not 1, you're finding factors of A and factors of C and putting them into your binomials until you find a combination that works when you check your outer and your inner. With guessing and checking, you have to make a guess. You've got to be willing to make that initial guess. Otherwise, it's going to take you way too long. I'd rather you guess and then erase and fix it than just sit there and stare. The next trinomials were those longer ones. So the A value is still not 1, but A and C had lots of factors. So it was taking you too long to try to guess and check, and that's where we could use the method from yesterday, which was called the grouping method. The example that's here is using the grouping method, although if you look at this problem, A and C really don't have a lot of factors, so what method would I prefer you use on that example? And yes, the answer is I'd prefer you did guess and check. Okay. However, this is just an example to show you how the grouping process works. And the last way of factoring with 3 terms is the one that we just talked about, and that is the perfect square trinomials. So the first term and the third terms are perfect squares, and you should always test the middle to make sure that that works out as well. And there's an example of that over to the right. So those are all the factoring strategies. Got to make sure you practice them all. The more you practice, the quicker you're going to get, the better you're going to get, since we'll be factoring from now until June. Factoring will not go away. You have some homework on this tonight. And like I said, tomorrow you guys are going to do some practice, and the day after you have a skills test coming up. And that is all on factoring. The next time you guys hear my voice, if you are deciding to watch these, we will be moving on to the next section, which focuses on rewriting a quadratic from one form into another form. See you later.